Okay, so today we will dive headfirst into object-oriented programming, or as it's usually called OOP. We'll talk about what makes up the object-oriented programming, how to use it, how to not use it, and especially how it works in JavaScript, because the programming language of our choice is quite peculiar in the object-oriented paradigm. So let's see at our agenda. We'll first learn what are objects, first in paradigm, and then how they are especially applied in JavaScript. Then we'll talk about four main OOP principles. We'll talk about different ways how we can create an object in JavaScript. We'll learn how to use inheritance in JavaScript and what is the difference between inheritance and composition. So, even though this topic is kind of heavy, we decided to make it lighter with this presentation, so it's not very serious. We'll be going by the famous film The Fifth Element. So first we will start with Super Green with classic OOP because it was not created for JavaScript. JavaScript is quite a young language. First, this paradigm was being used in C++, C#, Java languages. Then we'll go into Divine Light. We'll learn how the object-oriented programming was created, what's its intended purpose. Then we'll see how this intended purpose changed a bit in Diva, how it is applied in JavaScript. And finally, we will wrap our lecture at multipass. So let's dig in. First, what is object-oriented programming? This is a quite complex topic, and usually it's described kind of like the meme picture on the right, like first draw two squares, then something something. Now you have an amazing all. This image is like photorealistic. So I've tried to do my best to not teach you OOP in such a way, and between this one step two circles and two step, the finished picture will have lots and lots of slides in the middle to make it easier for us. So what is an object? Because object-oriented programming is all about object. Object is the data and behavior enclosed together. It's a data type. So, for example, if we look at the owl in computer science terms, we can think about this owl as an object. It has some properties. For example, this owl has two wings, two eyes, two legs. Maybe it has a Boolean property like has feathers equals true, because our owl does indeed have feathers. Also, it has access to some methods, functions. For example, we can add a method to our owl object, fly, and we will write the function for owl to fly, or eat mice, and our owl can eat mice. As of now, we're just talking about a concept, but let's see how this is executed in a code. When you were studying JavaScript basics during previous lectures, I suppose you have seen such code. So let's create a constant called animal, and it will equal to a function. So in this function, we are passing one argument called sound. And we are also creating a function called speak, which will console log the sound which we input to it. And then we will return the function as a whole. So object equals data plus behavior. We are inputting some data, the type of sound, and behavior. For example, logging out the sound. So here's an object. In JavaScript, it is signified by this curly parentheses. And if we stringify it by calling the method toString, then we will see the object string. It shall be noted that object is quite different from an array. When we are working with array, each item has its own index, and we always know that in arrays, index starts from 0. So the first item in an array will have index 0, then 1, then 2, and so on and so forth. But object is different. You cannot call any property on an object by using index. They can be mixed up. They don't have such strict order as in arrays. And you also cannot use the for loop when working with objects. Arrays and objects have different syntax for iterating through its items. For object, the correct syntax is for in, as shown at the right part of this slide. For key in object, for variable in object, and the variable in the object case is a key, as we will see later down the line. So, for example, here we have a user, it has some name, it has some surname, and then we can define property by using different means. For example, when you create an object, you can create it as an empty object, or as in this case, it can already have like first name and surname. But another method with which we can add a property is called define property. For example, we here are calling the object.define property method and passing in first our object user, second argument the property name we are trying to add, and then we are passing an object with a function which will be doing this calculation, like it will be putting together first name and surname to give us the full name of this user. And if we call it, we can see that full name is being logged to the console. Our objects are quite strange beings in JavaScript, and they have special properties called descriptors. So, as with any object, we want to be in control of what we can do with it. So, for example, the simplest descriptor is value. As you can see in our example, the user has first name and a surname. Also, there are three properties which configure the object. For example, writable. If you define the writable property and set it to true, and it's by default true, it means that you can change the property. For example, if you write user.firstname equals Jana, or user.firstname equals Stanislav, or any other name, it will be changed successfully. But if we set this property writable false, then this change will not be applied and we will get an error. This is a nice way to preserve our objects if we do not want them to be changed in ways we don't want to. Next, our object is enumerable. Enumerable means that when we are using the for in loop, which we have seen at the previous slide, the for in loop, if the property is enumerable, it means that we can count it in such a loop. And if we set the enumerable to false for some property, then we will not be counting it in the for in loop. It's quite useful when, for example, you're writing some new functionality with a legacy project, and lots of functionality is based on the for in loops. But you need to add some new properties to this object. You need to add these properties, but you do not want to break the existing for in loops. Your property does not need to be there. So you can set the enumerable property to false, and your new property will not be counted in these for in loops. And the third property we can set is configurable. If we set it to false, by default it's true, then any descriptors cannot be changed and the property cannot be deleted. So there is a big difference between writable and configurable. Writable means that the property may be changed or may not be changed. Is writable is false. And configurable, we can freeze our object with configurable. If we set configurable to false, then the property cannot be deleted and cannot be changed. So it's more strict. And also, object gets access to get and set descriptors. These are called accessor descriptors. And with them, you can use them as an interface, as a means to communicate with your object. So, for example, you want to get the first name of the object, of our user object in this test case. If you do not want for this object to be accessed from outside, you can write a special method, get, and using this, you can write a get function, as we can see in the example, which will be returning the first name and surname. And for setting, well, as it is said, this property can be used to set some new value. So get is for getting without changing the value, and set is for setting the value, changing it. So we have talked about objects briefly. Now let's finally talk about object-oriented programming. So this is a paradigm based on the concept of objects. These are data structures which can contain both data and methods to change it, code to change it. Data can be in the form of fields and code in the form of procedures, as they are called in C++, C#, Java, the programming languages from which the object-oriented programming originated, or in JavaScript, these are called methods. So the main feature of objects is that an object on procedures or methods can be accessing the data on the object and usually modified as well. Let's talk about the first part of our lecture, the super green part, the classic object-oriented programming. So, OOP concepts, there are 4 of them, but the most important of them are these 3: encapsulation, inheritance, and polymorphism. There is also usually abstraction mentioned as a 4th one, and we will talk about it today, but, well, no pun intended, but abstraction is quite abstract even in OOP, so we usually focus on first 3. Let's see. As I told you, we also have abstraction, but it's a funky one. Let's talk about more simple first. Encapsulation. What does encapsulation mean in regarding to object-oriented programming? It refers to bundling the data with the methods that operate on that data, or restricting the direct access to some of the object's components. So, what does it mean? Objects provide us with very good means to bundle together data and the methods to change it. And by encapsulating, like hiding how this object work, we provide our users with only the interface to manipulate our object. So we are protecting the data from being directly manipulated, but we are providing means to the user to change it through getters, setters, other methods, but we are prohibiting them from like changing the data on the object directly. So we are enclosing and decoupling the data from outside. And by using objects, we can very easily achieve this. Usually enclosing the data from outside means using private fields. And in TypeScript, we already have them. TypeScript is like an extension of JavaScript, which is widely used in e-commerce today. And TypeScript, first, it enhances JavaScript with types, and also it gives us access to several new keywords, for example, making the object fields private. So, for example, if I have an object with a field name, and I set in TypeScript that this field is private, then if a user tries to access it as user name, they will get an error because this field is private and it's impossible to reach it directly. For that, for example, they will need to use a get name method, which I have specified on this object previously. JavaScript is also trying not to lag behind, and private fields will be included in vanilla JavaScript very soon. They have already been added to specification. And also there are many libraries which we can use while programming with JavaScript, which gives us access to making our fields private, to hiding the data on our objects. So, What shall be noted that the object-oriented programming is not about the implementation details. So encapsulation can be achieved in different ways. Let's see how encapsulation can be achieved with closure. Closure is an interesting JavaScript concept. It means that the function can get access to the variables and functions defined in the outer function, even after this outer function have been removed from the call stack. So here we see our example with an animal. Const animal equals a function. We have the let sound, and then we have the function speak. And we, in the end, reveal speak as a public method, so we are returning it. But for example, the sound variable, it cannot be accessed outside this constant. But by calling this speak method, like owl speak, pig speak, we can still be using this sound information, the value, the data, which is encapsulated inside the animal constant. Like if we try to just directly access the sound, it will not work. Like we cannot access the let sound variable because it is inside the animal function. But with the speak method, we can get its value, and that's encapsulation. There is also a very popular pattern. It's called reveal model pattern, and it's very frequently being asked on interviews to write it, and it means that you are hiding the value. One of ways of achieving the reveal model pattern is using the closure in JavaScript, but there are also several other ways to achieve it, so I'm highly recommending for you to read up on the reveal model pattern to be ready for technical interviews in the future. It's not guaranteed that the interviewer will ask you this, but it is indeed a common question. The next one after encapsulation is inheritance. Inheritance is a mechanism of basing an object or a class. We will talk about class a bit later down the line during this lecture. It's basing an object upon another object by retaining similar implementation. So, for example, I have an object called an animal, and I want to create something which has all the properties and methods of an animal, but also has something else. For example, I have this animal object, and from that I can inherit a dog and add some new properties and methods. For example, my dog can bark, or it can chew my shoes or something. And I can also go a totally different path and inherit a cat from the animal object. Cat is quite different from the dog, but they still have like a common ancestor, a common base, the animal object. Let's see how it's working. So with inheritance, we can extend the original object with behavior and with data. Here we have the already familiar constant animal, and then we are creating the owl. We see that owl equals an animal, and our owl can fly and it can speak as well. So it has inherited what was on animal, but it can also fly. We have added an additional method for it, and only owl has access to the fly method because we have established it on it. Animal can't fly, but owl can both speak and fly. That's inheritance. Inheritance can be quite simple or it can be quite different. For example, the very simple single inheritance is that we have our parent object, the animal, and then from that we inherit the owl. Or we can have a longer chain. For example, we have an animal, and then we have the bird, and finally we have the owl. And also there is what is called the multiple inheritance. For example, there is animal, bird, then an owl, and in parallel we have several services which can also be inherited by the owl. It shall be noted that multiple inheritance is not applicable to JavaScript. It does not support it. So in JavaScript, you only have access to single or multi-level inheritance. What shall be noted about inheritance? That it shall not be overused, because it can lead up to our code being very complicated and very hard to maintain and extend further. For example, you have an entity in your code, this animal, and then you decide to make an owl from it, and then you need to extend the owl, and then in parallel from owl you also extend the dog. Next we have the small dog, next we have the small dog with ears, and so on and so forth. And if these inheritance chains are getting longer and longer, when you're changing something, for example, on animal, on like the parent object, this affects all the objects which have been inherited from it. So one change can cause like a wave-like effect throughout your application. It will affect lots and lots of objects. And it's very hard to debug. If you have a really long inheritance chain and something happened in the middle, it can be very hard to pinpoint the exact stage of inheritance where this bug actually appeared. Like you see the problem on the like sixth inherited object, but in reality this problem originated from a totally unrelated pull request which accidentally touched like the second object in this chain. So inheritance shall be used in moderation. It's very powerful, but its overuse can lead to some bad situations happening. There is a very, very old battle in front-end development and with development as a whole, inheritance or composition. Inheritance is an object-oriented concept, and we have just discussed it briefly. And composition, it's from a totally different field. It's from the functional programming. If in object-oriented programming everything is an object, like the object is our building block from which we are building our application. In functional programming, a function is our building block. And composition means chaining several functions together to achieve similar results as inheritance. Composition is outside of the scope of our lecture, but if you are interested, you can also read it up because object-oriented programming or functional programming, what is better? This is always a hot topic, but I suppose the main takeaway is that both OOP and FP, which is the short name for functional programming, both of them are no more than instruments, and you shall be familiar with both and be using the instrument which is better suited for this situation. So, at least from my personal perspective, it's not a good idea to discuss like which one is better, object-oriented or functional. They're both good. One is better at one things and the other is better at other things. Next, polymorphism. This is a pattern in which our classes or objects have different functionality while sharing a common interface. So, for example, in our speak method, even though it's a common interface, speak, different animals have a different functionality. So, for example, the dog says woof, the cat says meow, like what does the fox say as in famous song, and so on and so forth. So the method is one and the same, but the outcome is different, and that's polymorphism. So polymorphism, to sum it up, is when a single entity could have different forms. It's a powerful concept. It allows us to not be repeating ourselves in our code, but it can also lead to a kind of guesswork. For example, let's see our animal, and we can easily override the speak function, and instead of telling us the quack or something, it will be telling us I have no words. So on one side, polymorphism is very powerful, but on the other, it can lead to some changes that you did not anticipate, because it's very easy to override something and you expect the speak method to do one thing and now it's doing the other thing. JavaScript relies very heavily on polymorphism. JavaScript does not have rigid types. So for example, when you create like let A, you can store anything you want in it. You can store a string, a number, undefined, null, boolean, object, function, array, and you can override it again and again and again. Even if you define it with const b, for example. Yes, you cannot override const b from string to number, for example. You cannot override the primitive value. But in JavaScript, there are two types of values, primitives and object, which is passed not by value, but by reference. So even if we have const b equals an object, we can still add properties to this object, delete properties from this object, add new functions, override these functions on the object, even though b is defined as a constant. So JavaScript is a very easy language to pick up because of polymorphism, but again, because of polymorphism, JavaScript can be a little buggy and hard to predict what the outcome of your code will be, and it can be a little hard or very hard to debug. So, for example, TypeScript, about which I've been talking recently, it strictly diminishes how polymorphism can be used. So in TypeScript, we have strict types, hence the name TypeScript. So in TypeScript, when you create a variable, let A, then you write let A string and then cat, for example. And if you try to create let A string equals number 22, then you will receive an error. So TypeScript is really going hard on polymorphism. It's severely discriminating against it. But polymorphism is powerful, but it can be very buggy. Hence why TypeScript does not use it, and TypeScript is mostly used in bigger, more complex applications where there are lots and lots of people working on it. So if JavaScript is usually more like indie language for smaller teams, in bigger projects, in enterprise projects, TypeScript is used more and more frequently. And if you look at the usage data, TypeScript, it is thought that it will supersede JavaScript in the nearest future because this language is more strict but more predictable. So, polymorphism, it can be a problem, but if you do not rely heavily on inheritance, then your polymorphic problems will be lesser. And the last one, the strange one, the abstraction. The abstraction is a concept which means that we hide internal implementation details. It can be quite easy to be mixed up with encapsulation. And encapsulation, as we have talked previously, means that we are hiding the data from the outside world and providing an interface to manipulate it. For example, we were not able to access the sound property on our animal object directly, but we were able to output the value of the sound variable by using speak method. Abstraction, it is not about the implementation, it's about how we are designing things when we are thinking in the object-oriented paradigm. So when we are writing our inheritance chains, when we are thinking about the architecture of our application, we first are like making broad strokes. We are not concerned about the teeny tiny details of our implementation. But as I said, abstraction is strange, abstraction is abstract, and usually we are only focusing on the first three, on encapsulation, on inheritance, and on polymorphism. But if you want to understand what abstraction is, just imagine that your application is a box As in this picture, there is some interface which allows you to manipulate it, but you shall not be concerned like with implementation details. How it works is not your concern. The main thing is that it works. So, the wrap up on the classical part. These concepts, the encapsulation, inheritance, and polymorphism, they are not unique to object-oriented programming. But if you want to understand how to write better code using inheritance, using polymorphism, especially in JavaScript, you shall be familiar with these concepts. But the main takeaway from this first part is that objects are simply the containers for encapsulating data and giving us access to methods with which we can manipulate this data. So, a bit of history lesson, the origins of object-oriented programming, why it was created and how. So, object-oriented programming, it was invented by Alan Kay, the famous mathematician. The original concept was not even about inheritance, but about the messaging, about how we can transfer data between entities. So in its origin, object-oriented programming means that everything in our application is an object, and this objects, they need to communicate to each other somehow. And with these concepts of object-oriented programming, even without inheritance, but with already encapsulation and abstraction, we can create a communication network between these objects. So the objects are hiding the implementation details, but they are providing like some methods, some buttons which other objects can push, can use to communicate with each other. So objects are kind of like black boxes in the very beginning. You don't know what's inside, you don't know the implementation details, but if you want to get something from this object, for example, you want to get the value of the sound from the animal object, then you can push the speak button and it will give you the value of the sound. But you do not know how it works under the hood, like the object itself, its contents are concealed from you. And all these objects are communicating with each other in your application. They're like bundles of encapsulated hidden data with outside-facing interfaces, which allow our other objects to communicate with them. So, when we have started building interfaces, the OOP shines when interface objects are conceptually real objects. When we talk about modern day applications, most of them are just lists of data. For example, when you are using Twitter, when you are using Instagram, when you are using Facebook, what you are seeing in essence are some objects of data. Like each post has a date, a name, a text content, like a like count, etc. And all this information can easily be represented as properties on an object. And if you want to communicate something to another object, then you can use a method like, for example, update the number of like or like this post to increase the number of likes. You cannot change the number of likes by just writing like post dot likes equal 5 or something, but you can call the special method, which is facing outwards and allows you to communicate with this post object and change the number of likes on it. So as most of the data currently used in web applications and in mobile applications is an object, and one post is an object, and the list of posts is an array. So usually we are dealing with arrays of objects in our applications, the absolute majority of times. When you are, for example, scrolling your thread in Facebook, what you are seeing is an array of objects, a list of posts made by your friends and colleagues. Same goes for Instagram, for Twitter, for LinkedIn, for anything and everything. So, how does this all tie to JavaScript? Objects allow us to store functions associated with data. We already know this. So here's a simple object. For example, here's a variable called friend1. It has name, it has national city, and it has a method called say hi, which allows us to console log Ivan says hi, or as it's written here, привет in Russian. How we can create objects in JavaScript. There are several methods which we can use. Well, the first one, I suppose the most intuitive method, is just creating objects as we have created our Ivan object. Just write in a variable, write an equal sign, and then using the curly braces, we are creating an object. But it's only one way. So here on the left, here's how we created our all object. Next, in the middle, we can see that we can create it using a function, because in JavaScript, all functions are objects, and all objects can also be called as functions. When you have been studying the data types in JavaScript, there are 8 of them, but there is no such data type as function. There is only an object. So if you were wondering, function is an object in JavaScript. So we can create function owl, and then using the this syntax, of which we will talk in more detail later today, we can in the same manner create new properties. The sound property equals to string hoot, and then we can add the method speak method, which in itself equals a function which logs to the console the sound. Here's our owl again. Even though the implementation details are different, it's the same owl from the end user perspective. And thirdly, we can be using classes. Class, it was introduced to JavaScript in years 6. It is quite modern, I suppose, but again, we are living with year 6 for some years right now, so I suppose we shall stop thinking about classes as something modern anymore. But class is like a syntactic sugar above functions, and it allows us to write our owl in a different way. Class is like a blueprint. In first two ways, when we are just creating constant owl or function owl, this is like the owl itself. But with class, first we are creating a blueprint for our owl. So when we write class owl, we invoke the constructor, then we say that our class owl will have access to sound, and it will also have method speak. I cannot call this speak method on this owl. This owl in class does not exist yet. Class is a blueprint, and then from this blueprint, I'm creating my owl. Let owl equals new owl. So I'm creating an instance. And then on this instance of the class, I can call these methods, I can use it, and so on and so forth. So in the first two methods, I'm already creating an instance of the owl. And in the third one, when using classes, first I'm creating a blueprint, and then from it, I'm creating an owl. So classes are very useful when by using like the same blueprint, you want to create several different objects. For that, classes are awesome. So what are the other ways to create objects? We can be using object create. So on the left, we have what is called the dot notation. We can at first create the empty object, and by using dot notation, add the properties we want one by one. I suppose you've done this many times before. And on the right, we have the object create. Object create, it's a special method which allows us to create an object based on another object. So this is how JavaScript, one of the ways in which JavaScript implements inheritance. So when we are creating my variable friend free equals object create, and here I'm passing null. When I'm passing null, it means that friend free will not be inherited from anything custom. It will just be a regular JavaScript object. But if I wanted to inherit my friend free from animal, for example, then I would write something like that. Variable friend free equals object create, and here I will pass in as an argument my animal object. And then friend free will be created as an object inherited from animal and will have access to all properties and methods defined on an animal. Before classes were introduced in year 6, JavaScript developers still had to write blueprints for creating multiple instances of similar objects, for creating instances based on like the same base. And for that, constructor functions were used, or as they're also called, the factory functions, because what factory does is stamping very similar objects one by one. Let's see how the factory function works. So here we have the function called friend creator. This function accepts three arguments: name, nationality, and greeting. Then inside of this function, first we create a new empty object, and then we assign the properties which we passed inside this function to this object. So we are assigning our new friend object a name, nationality, greeting, and we are also creating the say hi method. In the end, our friend creator factory function returns this new object. And if we invoke this function and pass their name Jean, nationality France, and greeting bonjour, we will create an object with such properties. So factory functions are like predecessors of classes. When we previously, before year 6, wanted to create something which allows us to stamp many similar objects, for example, in a moment I will want to create an object called Yana from Russia and her greeting will be Privet. Or I will want to create John, he is from USA and his greeting will be hi, and so on and so forth. So these factory functions allowed us to create new objects to stamp them as a factory very easily. If we want to inherit our object from something else, then we can be using object create. For example, here we have another factory function, friend creator 5. It accepts the same parameters, name, nationality, and greeting. But here, when we are creating new friend, we are invoking the object create method from in which we are passing the friend actions. Let's go a bit later in this code and we can see that variable friend actions is an object in itself. And on friend actions, we already have the say hi method. So we are inheriting our new friend object from friend actions using the object create syntax. Then, in already familiar way to us, we are adding new properties, name, nationality, greeting, and then we are returning our object called new friend. And we can also create an instance of this object and be using it in the future. What's the main benefit? You can be writing these inheritance chains using the object create, because every function in JavaScript is an object. You can be writing these long, deep chains which allow you to extend functionality incrementally as you need it. So in the future, if you want to add another method to all instances of your friend creator 6, for example, then you could write a new function called friend creator 6, and your new friend variable will be created from object called friend 5, for example, and it will have access to all of its properties. When we are writing these factory functions, we are writing lots of what is called the boilerplate code. The code which is needed, which is repeated, but it does not add any like business logic. It's just what we have to do. For example, when you are running the factory function, each and every time you have to create a new object and then return it. And also, if you are doing inheritance, you have to create a new object, bind it to its parent, and then return this object. So you're repeating these actions again and again and again. So in JavaScript, the new keyword was created, and it takes these actions on itself, which simplifies our syntax, simplifies our code. So let's see how we can rewrite this function, this friend creator, using the new keyword. Function friend creator accepts already familiar to us properties, name, nationality, age, greeting, and then we are just saying that this name equals name, nationality equals nationality, age, greeting to greeting. We are not manually creating an object. We are not manually returning it. We do not do anything. Instead, we can add this new method, say hi, to the prototype of the friend creator. Inheritance in JavaScript works based on prototypes. Previously, when we were talking about how OOP works in other languages, we discussed that there are several ways you can do inheritance. There is a single chain, a multiple chain, and there is like a double inheritance, triple inheritance when several paths converge together. In JavaScript, only single and multiple inheritance is available to us. And this is because the inheritance in JavaScript is based on the prototypes. What does it mean? In JavaScript, each and every object has what is called a proto property. And in this proto property, there is a link to an object which is the parent of this object. And this chain, this link of prototype, or how it's called the prototype chain, it goes farther and farther till the very first object. For example, in JavaScript, all objects are being inherited by prototype from the object which is written with the capital O, object. And that is why your objects already have access to lots of methods when you create it. So uh, even not only objects, but even primitive variables in JavaScript, they have access to methods. So for example, I will write in chat, if you create, for example, let string, which is equal to meow, for example. And we all know that we can invoke the method, for example, string to uppercase, and it will correctly return to us meow. But how is this possible? If we run a console log string, you will see that the method to uppercase is not present on this string. But if you open console log further, you will be able to see what is called proto. And this is the link to prototype in JavaScript. And you will see that string is actually inherited from the object called string from the capital S. And on this string object, we have all these methods to uppercase, to lowercase, stringify, and so on and so forth. And that is how JavaScript is working under the hood. So if you create like a const number, which is equal to 8, and if you open it in console, then you will see that it's actually inherited from the number object, and it in itself is inherited from other object, and all objects are inherited from the object, from the capital O in JavaScript. And when you are running this method, for example, let string equals meow, and you're calling string to uppercase. How is this possible? String is a primitive. It's just a string. It does not have access to methods. What happens under the hood is that string is being boxed. This mechanism is called boxing, unboxing like wrapping and unwrapping, is being boxed inside an object. And this object, string, has access to this method. So this object access to case method. So this method is run, we receive our result. And after this method is run, string is being unboxed to become a primitive again. And this is how everything is working in JavaScript. This is how you're manipulating strings, numbers, Boolean types, anything and everything. And as we have discussed before, functions are also objects in JavaScript. So if we return to our new keyword on our slide, we can see that when we are adding our say hi method to prototype, it means that we are not adding it to friend creator itself. We are adding it to an object above. We are adding it to prototype. This is very good for memory usage because in our previous examples, each and every friend has this method. So here we have each object, each instance of this object having name, nationality, greeting, and say hi method. But say hi method, we do not need to duplicate it, like to spend more memory, to have an instance of this say hi method on each and every object. It will be much better to store it somewhere once. It's a function. We are just invoking it. Yes, each object needs its own name, nationality, and greeting. But say hi, it's universal. It can be reused by different objects. And so if we add it to prototype, it means that all of our friends that we are creating using this function, they will have access to this method thanks to the prototype, as we have just displayed with our examples in chat. So we are adding this say hi method to prototype, and we are also adding another method. Prototype is an object in itself. So using dot notation, we can be adding more and more properties and methods to prototype. And then we are adding another method, tell about yourself. And it's a bit different. Then we create two variables, friend6 and friend7. We pass everything here, our name, nationality, age, and greeting, and both of them will have access to say hi and about yourself. Even though if we try to console log them, we will not see this method. We will have to expand it in the console and see inside the prototype. And that's how we will understand that both friend6 and friend7, they both have access to these methods. They inherit them from their prototype. So to sum it up, what does the new keyword do? It creates for us a blank plain JavaScript object. It adds a property to the new object, the proto, that links to the constructor function's prototype object. So it is inheriting our object from its parent for us. And then it binds the newly created object to this constant. And it also returns this, or returns an object if the function does return it. I suppose by now you are asking what is this in JavaScript, and yes, we will talk about this topic during this lecture because this is a little bit tricky. As we have discussed before, arrays and functions are also objects, and that's why we are able to inherit them and to have access to all of these methods. In chat, we have discussed the string example, and here, for example, in multiply by 2, we can also run to string, like we can stringify an object, we can stringify a function, but this toString method, it's not described on these objects, but it is described in their prototype. And that's how we are accessing it in JavaScript, and that's how everything works in this programming language. So when we are inheriting something, for example, we have an object called human, it has a name and two methods, say hi and walk. And from there, we can diverge our paths and using this human as a common template, create a singer, which will have an access to additional method called sing, which accepts a parameter sung. And we also may create an athlete, which will have, in addition to name, walk, and say hi method, the athlete will also have a new parameter called discipline. So let's see about our prototypal inheritance once again to understand it better. Here we have our function animal, and as you can see, it is not a factory function. It's much simpler. Our function animal, it is an animal in itself. So we are creating the sound, the speak, we are creating the function owl, and then we can manually add owl prototype equals new animal. So here we are manually by ourselves adding all methods and parameters that animal has to owl. And for example, our owl can now speak. This method is not defined on owl, it's defined on an animal, but our owl still has access to it thanks to inheritance. If we are doing the same with classes with new ES6 syntax, it will look a bit differently. So in classes, we have our constructor, and we are assigning this sound, we have speak method. We can see that in our function we were using this, but in class we are defining our methods like in a separate object inside our class. And when we are using classes, inheritance is very easy. When we are using functions, we have to like manually connect the prototypes. Old prototype equals new owl and so on. But when we are using classes, we are just able to use the special keyword called extends. So our class owl, it extends our animal. And this means that our class owl will have access to all properties and all methods defined on an animal. And when we are using the extends keyword, we shall also be calling the super method in the constructor of the class. This means that we are invoking the class owl with everything that we already have on our parent class animal. And then we are adding the value, we are rewriting the value of sound using the polymorphism. So previously sound was an empty string and now it's equal to hoot. And when we create new owl, both classes and functions can use this new keyword. Our owl will be able to speak. So the result will be the same. It is still hoot. That is being logged to the console. So let's see some other example about how we can write our inheritance. First, we are writing a class and adding some functionality. We have the function human creator. It just accepts a name, and this name equals name. Then we are adding to its prototype, so not to the human creator itself, but passing it later down the prototype chain. We are adding the say hi method, so everything created with human creator will have access to this method, but it will not be present on them. It will be present on their prototype later down this chain. And we are also adding the walk method. Then we are creating a singer creator on the right part of this slide. And here we are calling human creator and passing here this name. So when we are calling it, this is a special syntax. It is syntax for binding the context. So we can bind context with call, with apply and with bind. So here we are calling the human creator function in single creator. So we mean that can you please call the human creator function, and you will use not its own environment, but you will use the environment of the single creator. So we are passing it here, and we are passing this name. And then we are able to inherit the properties and methods. So we are connecting the prototype, single creator prototype will equal to object create, and we are passing the human create a prototype, adding some new functionality, and then finally we are able to create our new human. And our new human will be created using single creator. It will have access to new method sing, and it will also have access to our methods say hi and walk. Let's see how polymorphism works in JavaScript. So here we have our athlete creator. If you remember, we described that there are two possible paths that we want to try. In this experiment, first we created a singer, and now we are creating the athlete. So here we are creating athlete creator function. We are calling our human creator, and then we are adding the discipline. And then we are creating our Usain Bolt and new athlete. And our Usain Bolt object, it has access to walk, it has access to say hi, but our athlete will not have any access to our sing method. So singer can say hi, walk has access to name and can sing. Athlete has access to say hi, to walk, to name, and discipline. But athlete and singer, they do not know about each other. They are not connected. So athlete cannot, by using its parent, somehow get access to the sing method. This chain is only going one way. So athlete has access to information we have on human, but it does not know anything about like its neighbor on this chain, the singer. Athlete and singer are not connected in any way. If we do the same thing with classes syntax, we can see that we are creating the human creator class. We are using the constructor, passing in the name, we are defining the walk and say hi methods, and when we are separately creating single creator class and athlete creator class. They are both extending using the new keyword extends. They are both inheriting from human creator. So the code on this slide and the previous two slides, it's absolutely the same in that it achieves the same functionality. It's just that in JavaScript we have the older syntax, the function, or it's called prototypal inheritance, and the class inheritance. Class inheritance is still using prototypes under the hood. Anything and everything is using prototypes in JavaScript under the hood. But it still allows us like a new abstraction above it. So when you are using classes, you are not writing prototype chains by yourself. Classes provide you, like for example, this extends keyword. When you are using extends, classes are doing many things under the hood for you, like creating prototypes and so on and so forth. So classes can be viewed as an example of abstraction. We are not into the implementation details, but we are provided with several methods to manipulate these classes. And here's an example of composition. When we are using composition, we are using simple building blocks to build something more difficult. Here, for example, we have the human function. And our human function has access to brain and legs. And you can see that brain and legs, they are defined using separate functions. So new brain, new legs. So they are created using some other function factories, and they have their own like methods, and they have their own properties. And then we can add to the human prototype some other methods. For example, think and walk. And we are able to use the brain and legs in these methods. And when we are creating, for example, new human called Vasa, a popular Russian name, then our Vasa has access to think method and to walk method. So in inheritance, you are starting from something small and then you are adding more and more functionality. When you are using composition, you can go the opposite way. You can create something more complex by constructing it from several parts, kind of like transformers. So here we are creating our function by combining the brain function and the legs function. If we look about at the schema on how the inheritance works in JavaScript. So let's go from the bottom up. As we have explained in chat, we have like objects from capital O, we have functions, and every object you create is inherited from the object, and function object is also inherited from object prototype, as we can see on the schema. And everything that is later down the line, it has access to things above it. So for example, the object you create, the function you create, or function called like my function, they all have access to first function prototype, and then this function prototype, it itself is inherited from the object prototype. So each and every function will have access to everything object prototype can do and function prototype can do. And this is how JavaScript is working. And also you can see different syntax here, proto and prototype. Proto is like a getter for these properties. As we have discussed previously, objects, they have access to set and get methods. With proto, you can get what is listed inside, but with proto, you cannot set it. So if I want to view what is inside the function prototype, then I can call function dot underscore underscore proto underscore underscore, and I will view everything. But using proto, I'm not able to change anything which is listed on the function prototype. So that I will need to use the setter prototype. If I write function dot prototype equals something, then I will set it, I will change it. But you shall be very careful when using this, because setters, they are changing the whole prototype at once. And if I set my function prototype, for example, to equal just a string called test string, for example, then I will lose all other information present on it. So usually it's a better, safer idea to not be overwriting the prototype as a whole, but to add something like function prototype dot say hi equals something. This means that we are creating a new property on the prototype and not changing the whole prototype itself. So, what are the pros and cons of using the object-oriented programming? Pros is that it removes unnecessary logic. For example, instead of multiplying the say hi function on each and every instance of our object, we can just define this function once inside the prototype and use it on every instance which is inherited from this prototype, which is very useful. And our code, it becomes simpler, cleaner, and easier to read and use, especially when you are using the new syntax, when you are using classes, when you are using the new keyword The cons are, of course, that inheritance is not easy to understand at first. And what we are explaining today, all these new words, how to work with prototypes, what is inheritance, what is polymorphism, I understand that it is a lot. So at first, object-oriented programming, it can look intimidating. But if you give it some time and try, for example, writing the examples we discussed at this lecture by yourself. Try writing simple inheritance chain, like creating an animal and then adding it some legs and a cute tail, and then inheriting some fox from this animal and adding it, your fox, for example, a nice red fur. Then it will become easier for you, and step by step you will be able to execute more and more complicated inheritance chains. Good thing is that in JavaScript we can only be using one chain inheritance. So in JavaScript it is impossible to inherit the object from several things at once. So that is nice. That makes our lives easier. But I suppose the most important thing that can be noted about the object-oriented programming is that it is not always needed, because using inheritance, it unavoidably adds some additional complexity to your code. You shall be wary about shall you be using this in this specific situation? Is it a good idea? Or maybe inheritance is not needed for implementing this functionality, and it will be better to use something simpler. So please do not overuse it. And now, finally, we would like to talk about this. We have seen this used in several examples during this lecture, so now let's finally look at it in earnest. So this is the basis of how inheritance is working in JavaScript. How is this strange word working? It is not defined when your code is created. This is defined when your code is being run. This is the main difference between closure, which we have studied during this lecture, and this as a keyword. So when you are writing your code, when you are using closures, you can be sure that, hey, this function is encapsulated inside this function. And so no matter where I invoke, where I call this function, I will still have access to everything defined on its parent function. With this, things are very different. With this, your code is being read by interpreter. As we have talked before, JavaScript is not a compiled language, it's an interpreted language. And that means that this keyword is not being run when your code is written. It is being assigned a value when your code is being actually run. And I suppose that can be very confusing in the future. So let's try to detangle this. This can be different in global context, in function context, in a constructor, in a method call, in arrow function. So where you are calling your function, where you are calling this method, calling it with parentheses, this is what defines the value of this. So, for example, if you have an browser window open and then you write this in the console, you will see that this, when you are writing this and the code is being run, this is being equalized to something. So when your code is actually being run, this is always getting changed to some value. In global context, this will be equal to window when you're running it in browser. If you are running your code in Node.js environment, then this, instead of window, will be equal to a global object. But you can just try it by yourselves right now. If you open the console, write this, then it will be equal to window in your browser. Then in function context, if we have a function called owl and we will write console log and put inside this. When you are just writing this code, you have this function owl and inside this console log in this. You don't know what this is equal to yet. It depends on where you will call this function. There is also such a thing called strict mode in JavaScript. JavaScript, due to it heavily using polymorphism and due to variables invoked using the keyword var being hoisted and having an undefined value at first, JavaScript can be very confusing and counterintuitive, as we have discussed previously. For example, if I write something like that, console a, and then let a equals 5. My console log will actually print undefined, because from the perspective of the interpreter, the code will look like this. First, we invoke let a, then console log a stays at its place, and then we are actually assigning a value to our a variable. So here how it looks from the interpreter perspective. And there are many things like that in JavaScript. And if you don't want to deal with this, like undefined is the worst thing that you can see when you are developing with JS, because it does not give you any information, like this is undefined. Why is it undefined? We did not find some information. Okay, but why we did not find it? So JavaScript can be very confusing when debugging it. And that's why use strict method was introduced. Strict mode, it is making JavaScript less unpredictable. So errors in strict mode, I've linked an article describing the strict mode in more detail in chat. The strict mode, it allows us to see errors in JavaScript more cleanly. Oh, sorry, I linked it in Russian. I will update the link right now to make it in English. One moment. This is better. So when you are using strict mode, it will allow your errors to be better viewed, to be more visible. And if we return to our presentation, we can see that if we try to use our owl and see in strict mode, then function context in strict mode will equal to undefined. We will not be able to use it. So strict mode prevents us from doing such things that will lead to unpredictable result. If we create a function owl and inside of it we have console log this and we create a new owl in this object, then we will see that this refers to an object. So in strict mode, we have a difference between there. But if we call the constructor without new, and we learned today that new is doing several important things for us. When you are running the new keyword, a new object is being created, it is being binded with the prototype you desire, and then it is being returned. This is new keyword is doing all of this for you, so you do not need to do it manually in your factory function. But you shall always invoke and create new objects when you're using the new syntax. You shall be doing it with new. So for example, if I create a function cat in chat, and then I will have like this name equals the popular name for cats in Russia. Here, I'm not manually creating an object, I'm not returning it, I'm not binding its prototype. So if I try to create a new cat, if I do something like this, it won't work because my function, the way I've written it, I'm not creating your object, I'm not returning your object. It's relying heavily on this. So if I want to be using this simplified syntax, I shall always be using the new keyword. So this syntax with new will work, and it's very important. And it can be very confusing because when you are creating your object, and this is not the code you have written. For example, this is the code that your colleague has written a year ago. It can be very cumbersome to go back, go see this class and understand, hey, this was written for new syntax and it cannot be run without new. Or was this written with old syntax and I can create new instances of the object without using new. So if we create this incorrectly, so if we call the constructor without new, then we will see that this is actually equal in non-strict mode to global. So it is equal to window. It's where the oops arrow is pointing. And this is obviously not what we wanted. We wanted this to be changed when the code is being run to our owl function, to our owl object. But instead, without the strict mode, when we made such a mistake, we will see that it's actually equal to global. But in strict mode, we will get an error. It will be equal to undefined, so we will not get the global context instead of the function one. Use strict mode is kind of like a predecessor of TypeScript, at least in my opinion, because what useStrict does, it makes JavaScript less sloppy, because JavaScript gives us tremendous freedom, but it is not always for the best, because it can lead to the results that we were not expecting. But on the other hand, it's very easy to program in JavaScript. Easy to write code, hard to debug. And when we are adding more and more blockers on this, like use strict mode, or we are converting our project from JavaScript to TypeScript, it's getting harder to write code. In JavaScript, you can just write like let owl equals owl, or it equals to a string, or it equals to undefined, and that's okay, there is no error. In TypeScript, it has strict types, it has interfaces, it has generics. TypeScript is harder to learn. But in TypeScript, your code results are much more predictable. Same as when using strict mode, your code results will be more predictable rather than when not using it. So most projects currently which are written in JavaScript, they are using this use strict. So you can put use strict in the very first index.js of your project and be using use strict mode everywhere on your project. So this is considered a good practice to be using the strict mode due to the unpredictability and maybe even too much flexibility of JavaScript. So this kind of puts like a cap on it. Let's see how this is behaving in a method call. We have our function owl. We have this speak. What does this mean? That when we are using this, when we are running this code, when we are calling new function, as in let all equals new all and parentheses, here we are calling our all function. And when we are calling it, this is being changed to something like this. It does not mean anything until the code is being run. But when the code is being run, dependent on the content, on the context, is this call being done from the global environment, from the function environment, from inside an object, inside a method, then this keyword is being replaced. And it is being replaced to the object. So on the second line, we can see this dot speak. And because this method is defined inside the object, when we are running this code, you can actually change this to owl itself. And that's why we can call this method on our owl. Owl speak method is working. But if we assign a method to a variable let speak equals owl speak, then we will see that the context is being lost. It's no longer referring to an owl. Why this is happening? So this is not being dependent on where it is written. So yes, first we have written this inside our owl function, but what is much more important is where we are invoking it, because for this it is not being set a value. It does not have a distinct value until the code is being run. So if we are running our code inside an object, like when we are creating an owl, by using the new keyword, and then we are running the method speak, then we are correctly referencing to the owl object. But when we are assigning a method to a variable, let's speak equals owl speak. Let's see, what is owl speak? It's just a function. It's a function that is put into the console the value of this. It is not yet binded or connected to anything. It's just a function. And if you run this function inside an object, it will return you an object. But if you assign a method to a variable and then run this method, well, we are running in global context console log.this. And as we have already learned, when we are calling this in a global context, we will get a window object if we are running this code in browser. So assigning a method to a variable can be very dangerous in JavaScript because you're expecting to receive an owl object as this, but instead you are getting the global object, the window. Arrow function. Arrow function is a peculiar one. Arrow functions, they were added in JavaScript, yes, 6, the same as classes. And arrow functions, they are actually not functions at all. They are what is called an abstract wrapper around a function. Arrow function has a much cleaner, better syntax. Like instead of writing something like function, and then we have something, and then we have like return 0, for example. So this is the classic function declaration. If we are using the syntax of an arrow function, the same code can be simplified extremely. So we can have just empty parentheses, then an arrow, and then our returning value, 0. If we are just returning a value, we can not even write the return, and we cannot even write the curly braces. if we want to save our arrow function to some variable, for example, it will be like const foo an arrow function, and it returns 0. Or if I want to be using the full syntax, then it will be like with curly braces. But again, arrow functions, they allow us to write much less text and achieve the same results. And unnamed arrow functions, the ones which do not have to be saved in a variable, they are very prominently used as callbacks. So, for example, if you have an array and you want to invoke there a reduce or a map method, so we have a const array, and it's equal to this array of numbers. And if I want to run a map method, I will be passing first an item, and then I will be passing in a callback. So I write it in row function. It will be very, very simple. So here is a map method which takes each and every item and logs it to the console. So arrow functions are very prominent in JavaScript because of their easy and clean syntax. But because they are not actually functions, but an abstract wrapper around the function, they do not actually have access to this. So if I write a function declaration with this inside it, so function var, and inside of it I have like console log. And if I run bar, this will be equal to bar function. So because I will be running this inside the function context, this will be equal to bar. But if I rewrite this function to an arrow syntax, so it will be like constant foo. One moment, let me write it. It will be like constant foo, which returns to us the console.log of this. And if I invoke this, actually this will be equal to window, to global, because arrow functions, they do not have their own this. This can be used both to your advantage and disadvantage. If you do not anticipate such a change, if you are not familiar with such peculiarities of arrow function, then yeah, there can be some unexpected results. So we can see that it, as in example on the slide, it will return us the global, not the object. But if you have a complicated object, if you have a method, and inside of it, you have again a method, as is seen in our example in sleep method. So we have our O object, it has a speak, defined as classic function declaration. Then we have fly, which is defined as an arrow function. Then we have eat, and eat is defined as two function declarations inside one another. And this you can encounter such a situation quite frequently in your work when a method is quite complicated and it consists of several functions inside of each one another. And finally, we have the sleep method, which is a function declaration. And inside this function declaration, we have an arrow function. So let's see what will happen after we invoke these methods one by one. First, we are invoking the speak method. It's written using a function declaration, so everything is working as we would expect. This in console log is referring to the object. Then we are running owl.fly, and here an unexpected thing happens because this is an arrow function. As we have just discussed, arrow functions do not have their own context. So instead of owl object, we are looking one stage higher, and one stage higher above is the global context. So here, because we are running this code in the browser, we are actually receiving the window object. So when you are using arrow function without being aware of this peculiarity, this will lead to results you do not expect. But arrow functions can be very useful when you know how to use them. Because let's look at the it example. Here we have the immediately invoked function expression inside our function declaration call. So here we have function and inside of it an immediately invoked function. So this is referring to the global context. And finally, when we are invoking the fourth and the last method, the sleep method, we can see that our arrow function is referring to the outer perimeter. It's not referring to itself in this. Instead, it is referring to the parent, and that's why we have the parent method being logged to the console. So when you do not want this context of the function, instead you want its parent, then arrow function usage is amazing, it's nice, and it will give you the results that you want without actually binding the context manually. So let's see what binding context manually means. For example, we want to manually set the context in which our code is being run. Let's see how this can be achieved. Bind, this is a special method which returns a new function with the custom bound context. Let's see. Here we have the all function with already familiar to us speak method, which is logging this to the console. So we create a new owl instance using the new keyword, and then we are like kind of repeating our old mistake from the previous slide. We are saving the method to the variable let's speak equals owl speak. And if we invoke this method in the console, we will receive the global. We will receive the global context, so this will equal to window because this code is being run in the browser. But let's see what we are doing next. Next, we are creating bound speak method. And here, let's analyze this new syntax. We are writing speak dot bind. As we remember, all functions in JavaScript are also objects, so we are able to use the dot notation with functions. And because all functions in JavaScript, they are inherited from the object with a capital O, we have available to us this bind method, even though we did not add it by ourselves. It is inherited via the prototype chain. So we are writing speak dot bind, and bind is accepting the context to which we want to bind this. And here we are manually passing owl, our instance of the owl factory function, the object which is created using this factory function. And now, if we run owl speak, then we will see that it's window. But if we run owl bound speak, we can see that it is referring to owl again. So bind is very powerful, and you will be binding the context manually in JavaScript a lot because there are lots and lots of cases when you using this to make the function reusable, because instead of referring manually to function parameters, you can just say, hey, this function is using this, and this will be only defined when this function is run, and it will be dependent on where this function is being run. But obviously, this can yield some results that we do not expect, so manually binding to the context that we desire is very useful. What is also important to be noted here is that bind returns a whole new function. So you have created the bound speak, and no matter how many times and from where in the future you will be calling this bound speak, it will always be bound to the owl. So bound speak is forever bound to the owl object. Bind creates a whole new function. Call method, on the other hand, it behaves quite differently. It is calling the function at the same time. It is binding the context one time and calling it. So let's see. We have our function owl with speak method, and then we want to call speak method one time inside the owl context. With bind, we are kind of creating a long-term commitment. We are forever binding the speak to owl. We have our new function called bound speak. And then we have to separately call it, as we can see, bound speak and then parentheses. But it is not always needed. For example, I want to call this function one specific time in my code, bound to the owl. I do not need to save this bound function. I don't need to call it bound in the future. And for this, call is amazing because as we can see, we are saying let's speak equals I'll speak, and then with one liner, we are just saying that speak call, and again, we have access to the call methods due to prototypal inheritance in JavaScript. And then I'm just passing the context. Speak.call owl, and the code is being immediately run. So this function is bound to the owl context, and then it is immediately run. But if I call speak again, like if I run speak call owl and then just invoke speak with parentheses, it will again point to the global context. So call is for binding the context once and immediately calling this function in this specific context that I want. So we are slowly approaching the end of our quite intensive lecture, how to use object-oriented programming. When we are developing web application, we are mostly creating some containers for our components, and most of the data that we are working with in our web applications is actually lists of objects or arrays of objects. So you will be usually using inheritance quite frequently in your project, if it is not written in functional paradigm. But functional programming is a topic for a whole another time. Object-oriented programming has a lot of pitfalls. So if you apply polymorphism wrong, or if you have a bug deep inside your extremely long inheritance chain, or if you did not freeze your object and the data can be still changed without using the setters and the getters, it can be changed directly. It can lead to some bad bugs and bad user experience. So I suppose the best thing that we can do is to just view the object-oriented programming as an instrument and to be using both the object-oriented programming and the functional programming as instruments in our day-to-day development. Because this course is entry level, we will not be talking about functional programming right now, because functional programming is a bit more advanced topic. It has been developed to us from mathematics. It has some very deep roots in some very high mathematical fields. But I strongly suggest for you to read on functional programming on your own in your free time and compare these two approaches. But object-oriented programming is like a norm for lots and lots of languages, for example, for C Sharp, for C++, for Java. JavaScript is a bit of a weird child because we are what it's called a multi-paradigm language. In JavaScript, you can be writing in object-oriented programming, in functional programming. You can be writing imperatively, you can be writing declaratively. JavaScript is a very free spirit language. Sometimes it can be too free, it can feel sloppy, and that's why we have things such as use strict and even TypeScript, which is being used more and more often. So with this, our lecture is coming to an end. I want to thank you all for staying with me through all of this mess of object-oriented programming. I'm sincerely hoping that this lecture was useful to you, that you learned something new, and I am encouraging you to try writing inheritance chains by yourself, because only in practice we can get a better grasp on object-oriented programming and on functional one, and actually on any other programming concept, because programming is actually a practical stuff. I like this comment. I think you understood the object-oriented programming very well. Yeah, I totally understand that object-oriented programming is quite hard to digest in one day. So these slides, they are available to you at Learn at your course. If you have any questions, please feel free to drop them in the chat, maybe not even now. I understand that right now you're just digesting this information, but maybe later, and obviously you will have a Q&A section where you can learn more about inheritance. And I suppose after this lecture, I will also drop some good videos that I would recommend on the object-oriented programming, same as we did last lecture with event loop. And with that, I'm going to wish you an amazing evening and have a great Wednesday.
Bye. Have a great night.
Bye. Thank you very much.